Hi, welcome to our 11th week of digital distance learning. This week we are going to continue our number lines, but we are going to do multi-step equations. So taking the one steps from last week and adding more steps to it, and we are also going to start word problems, which is really exciting, for me at least. If you don't like word problems, don't worry, they won't be all of it. Now please remember you need your notebook, you need a pencil or something to write with, and let's get started. Bye! In our first example, we see 3x minus 6 is less than or equal to 15. We are going to begin working on the left since my variable is on the left, and I am going to look for plus or minus. I see minus 6, so my opposite operation is plus 6. When I add 6 on both sides, I can cancel the negative 6 on the left, and I am left with 3x is less than or equal to 15 plus 6, which is 21. I then divide by 3 on both sides because I remember that 3 and no symbol next to an x means multiplication and the opposite is division. And I am left with 21 divided by 3, which is 7. This expression reads as x is less than or equal to 7. And now I can create my number line. Because I have to go up to 7, I would like to begin by changing my scale. Instead of counting 1, 2, 3, I am going to count 2, 4, 6. I am counting by 2s. My 7 is going to be located between the 6 and the 8, and I am going to color in my circle because I have that equal as part of my less than or equal symbol. And I am going to head towards the left with my arrow, the same as my inequality symbol. In example number 2, we have an equation, not an inequality, and we begin on the right side because we have a variable there. We see plus 11, the opposite is minus 11, and so I cancel the 11s on the right side, leaving me with 3x. And on the left side, I add two negative numbers. I am going to maintain my negative sign, and I am going to add 16 and 11, which is 27. Negative 27 is equal to 3x. The 3 and the x are multiplying, and so the opposite operation is division. I am going to divide by 3 on both sides, and negative 27 divided by 3 is going to be equal to negative 9, because 3 times negative 9 is negative 27. I like to switch this around and put the variable first, although with an equation, it doesn't make as big of a difference as it does with an inequality. This reads as x is equal to negative 9. Of course, I am going to now create my number line, and I am going to count by 3s this time. You can always choose your scale. And remember, you do not have to have 0 at the center. I am going to color in my negative 9 because it equals negative 9, but I am not going to draw an arrow because it is not an inequality. In example number 3, we go back to inequalities, but this time we notice we do not know whether to start on the left or the right because there are variables on both sides. When this is the case, you look for the smaller variable, in this case 1x, and you subtract it on both sides. Add it if it is negative, of course. 6x minus 1x is 5x, and we bring down the plus 3. That is all greater than 18, since x minus x was canceled out. Now I can begin as I normally would. I am going to work from the left because that's where my variable is located. And I am going to do the opposite of operation of plus 3, which is minus 3 on both sides. We cancel the 3's on the left, and we are left with 5x is greater than or equal to 18 minus 3, which is, of course, 15. Our final step is to notice that we have 5 times x, and the opposite of times is divide. So we are going to divide 5 on both sides, and we are left with x is greater than or equal to 3. We are going to write this, and remember there are two ways to write this: greater than or equal to 3, or more than or equal to 3. Both of these expressions are equivalent and interchangeable. Now let's create our number line. I am only going to 3, so I am going to create a scale of 1. I am going to place a circle at 3 and I am going to color it in because I have that equal sign that tells me color it in. Then I am going to follow my arrow towards the right since that is the way the symbol is pointing. In example number 4, we have -4 times x minus 2. And for this, we need the distributive property. We need to say -4 times x is -4x, and -4 times -2 is +8. And that is all greater to 16. We begin on the left because that's where our variable is, and we look for plus or minus. We have a +8, the opposite is -8 on both sides, and when we perform the operation, we are left with -4x is greater than 16 minus 8, which is 8. Now I have -4 times x, which means I have to divide -4 on both sides, and because I divided by a negative, I am going to remember to change the sign. This reads as x is less than -2. Our final step is to draw our number line. Again, remember you can start with any number. You do not have to have a 0 at the center, although it is nice when you do. You create a circle that is an open circle since we do not have equals, and we head to the left. For example number 5, we are going to have a word problem. It reads, you buy new tiles for a patio. Each tile costs $3, and you want to spend less than $1,000 total. $3 for each tile, and less than $1,000. Well, the question now is, how many tiles can you buy? Let's create an inequality to find out the number of tiles that we can buy for $3 each if we want to spend less than $1,000 total. Well, x is going to be my variable, and it is going to represent the number of tiles. If you want to use t or any other letter, you may. You get to choose what variable you would like. Now, 1 tile is $3, 2 tiles is $6, 3 tiles you would pay $9 because it is 3 times the number of tiles. $3 for every tile. That has to be less than, not equal to, but less than $1,000. We are going to divide by 3 on both sides to solve our inequality, and x is less than 333.33333 if you put this in the calculator. However, I cannot buy a third of a tile, so I have to say 333 tiles exactly. Not so bad, right?